Okay, all right, this is Unit 7, Day 2. Today is polynomial functions. So one thing that you have to always remember, it says n is the degree of the polynomial. So don't forget, that when it asks you to find the degree of a polynomial, it's always what its highest exponent is. So in this particular lesson for today on Day 2, we're going to explore cubic, degree 3, and quartic, which is degree 4. So we're only focusing on third degree and fourth degrees. Okay, so for example, if you're reading example 9 and it says f of x equals x cubed minus 5x squared plus 2x plus 8, that has a degree of 3 because x cubed is its highest exponent. Okay, it says using your calculator menu, analyze graph. So if you hit your menu button, well, first you want to open up a graph page. And if you hit your menu button and then number 6 says analyze graph, that's where you can find the zeros, otherwise known as your x-intercepts. You can find the minimums, you can find the maximums, and that's going to be key in this whole lesson today. Okay, so it says label the zeros and the turning points on the graph and round to the nearest tenth if necessary. All right, well, the zeros are pretty easy to see. The zeros are right here at x equals negative 1, at x equals positive 2, and at x equals positive 4. So you could write them out as coordinates as well, so I'll switch it up. Instead of writing x equals 4, it has the coordinate 4, 0. Okay? All right, so now, again, to find maximums, you're going to hit menu, then number 6, analyze graph, and I believe the maximum is number 3, minimum might be 2. So, and then you're going to highlight, so it's going to let you shade the lower bound, the upper bound. So you're going to shade just to the left of your maximum, just to the right of your maximum, and you click enter, and then all of a sudden that coordinate for that turning point of that maximum should be there. So when I rounded to the tenths, I ended up with 0.2 and 8.2. Okay, and please, please, please make sure that you're actually doing this in your graph. And then you're going to do the same thing. It's a separate calculation. So you're going to hit menu, 6, and then I believe number 2 is your minimum, and you're going to highlight the lower bound, so click enter. And then you shade just to the right of it, and then this minimum value should appear, and that is approximately 3.1 and negative 4.1. Okay, so again, please make sure you can get that. All right, it says, on what interval is f increasing? So now increasing means going up. So I usually teach the younger kids that if a graph is increasing, it means where the ant can climb up the hill. So it can go up from here. This is where it's increasing, right there in yellow, or from over here to here. So there's 2 separate intervals where x is increasing. Okay, so the first one, in interval notation, you read the x values. Why? Because you're reading it from left to right. So it goes from negative infinity all the way up until its maximum, and its maximum x value is at 0.2. Okay, neither of them are included. I use my union symbol or. And then this one starts at 3.1. Again, you always want the x coordinates. You're reading from left to right. That's the x values. And it goes to positive infinity. Okay, so what I have in yellow is where it is increasing. Part C wants where it is decreasing. So it's decreasing. It's going down where I've just shaded in green. Okay, so anytime it's decreasing, you could slide down. So increasing, you can climb up. Decreasing, you could slide down. Okay, in interval notation, again, you're starting up at your max, the x value. You're from 0.2 all the way to the bottom there at 3.1. Okay, so there's my decreasing. Part D, where is it positive? Positive means it's strictly sitting above the x-axis. So what I'm highlighting in blue right here is where it's above, okay? So there's 2 separate interval notations you have to write for positive, okay? Where is it positive? From this root over to this root. So it's from negative 1 to positive 2, or, again, shaded in blue, it's from 4 to infinity. So giving me x values. For all of these, you're reading the x values. Oops, even for part E too. Okay, now the next part says where is it decreasing? Decreasing means where is it sitting below the x-axis, and what I've highlighted here in purple is where it's sitting below. So this one, it's going from negative infinity to negative 1, or it's from 2 to 4. So that's where. These are very important that you understand the differences between increasing, decreasing, and positive and negative. All right. State all the x-coordinates of your relative maximums and minimums. Okay. Well, the x-coordinates, well, we only have one max on here. Okay, there's my max. And we only have one minimum on here. Okay. So if there were multiple maxes, they would all be relative maxes. So the word relative means all of them. So you're going to list all your maxes and all your mins. Okay, in this case, there's only one max and one min. Now it only wants the x-coordinate. So my max x-coordinate is at 0.2. My minimum's x-coordinate is at 3.1. If it didn't say x-coordinates only, then you would give me the whole entire coordinate. Okay? All right, part G, describe the end behavior. Don't forget, end behavior means what the y's are doing. So there's two separate end behaviors here. So you're going to write, as x approaches positive infinity, you need to tell me what the y's are doing. And then as x approaches negative infinity, you need to tell me what the y's are doing. Okay? Now, on the negative half, it's pretty easy. You can say, as you go this, what's happening to the y's? The y's are also going to negative infinity. Over on this side, some students get confused because you can say, oh, well, look, it's decreasing, and then all of a sudden it's increasing. But guys, the end behavior means just that. What is happening at the very end? At the very end of this, as x is going to positive, your y's are also going to positive. And you can put Control T and look at your table of values on the graph as well, and it's a little easier to tell. So you could tell that they're going to go down, but they're going to go up, and then eventually they just kind of stay increasing. So that's why x approaches positive infinity. All right, part H. Does f of x have any absolute? Absolute maximums or minimums means the highest of the high or the lowest of the low. And it's going to be no. And you might say, well, why don't I have a highest of the high? Well, because it's going to positive and negative infinity. If something is going from positive and negative infinity, okay, so this is as x goes to positive infinity. This is as x goes to negative infinity. These are the end behaviors right here. Then it can't have an absolute. So it's no because of the end behaviors. And because the end behaviors are going to infinities, then there is not an absolute maximum or minimum. Okay? All right, example 10. It says, for each of the following cubic, so all powers of 3, use your calculator to sketch. Now, guys, you have to make sure that these are accurate. So you don't want to just sketch them in and draw your favorite curve that looks similar. You need maximums, minimums. Look for the zeros. Look for y-intercepts. You need accurate points. So what I did was I put this on a graph page, and I find the maxes and the mins. So this one has a max of negative 0.7 and 10.4, and it has a minimum value of 2.73 and negative 10.4. Okay, it also has zeros at negative 2, 1, and 5. So I'm going to do my graph here. So this is negative 1, negative 2, negative 3, negative 4. It's kind of bad spacing. Negative 1, 2, 3, 4. And then positive 1, 2, 3, 4. Okay, so I said there's a 0 at 5. There's a 0 at 1. And there's a 0 at negative 2. So there's my zeros, my x-intercepts. Now I'm going to plot my maxes, my mins. So the first one's at negative 0.7, and then it's up. So now remember, this is positive 10. This would be negative 10, okay, because you're cutting those 20s in half. And negative 0.7 and then 10.4 might be somewhere right around here. So there's a max. So I know it at least goes like that, and then my graph can be accurate. And then I have a min at negative 2.7 and 10.4. So there's my min. Okay, so there's my as accurate as I can get on that one. Same thing. So ready? This one has a max, part B, has a max at negative 1.2, comma 15.2. And it has a minimum at 1.2, 2.8. Okay, so doing my scales here. So negative 1, 2, 3, 4. 1, 2, 3, 4. Here's 10. This would be 15. Here's negative 10. Okay, and so forth. All right, so the first one, I have a 0 at, it looks like it's at negative 1. It's at like negative 2 point something. And again, I'm sorry, I was copying what's already on my paper here. So you can look up, if you analyze the graph, so menu 6, 1, you can find the 0 right there, and you just highlight to the left and right of that. Okay, it does have a y-intercept at 0, 9, though. So if this is 0, 9, there's a y-intercept there as well. All right, the max is at negative 1.2, 15.2. So I get this little graph right here. And then it has a min at 1.2 and up 2.8. So it's not really that high right there. So then I have a min that goes like this. Okay? All right, last one right here, part C. You have a max at 1.8. And you have a min at 3.0. Those are nice ones. Okay? All right, and it has a 0 right at the origin. So 3.0. 1, 2, 3, 4. Here's 3.0. That ends up being a double root. It's tangent there. And then at 1, positive 8. So if this is 10, this would be 5. This would be 6, 7. Here's my 8 right there. Here's my 8. So at 1, 8, it's a max there. So it ends up doing something like this. And again, it's a tangent double root right here. Okay? All right, it says clearly a cubic may have 1, 2, or 3 real roots. Guys, this is huge, so know that. Cubic has 1, 2, or 3 real roots. And it can have as many as 2 turning points. Okay? So remember, it has 1, 2, or 3 roots. Okay, so this one is showing you, part A, that it can have 3 roots. This one's showing you can have 1 root, and this one can show you it looks like it's 2, but there's a double root right there. Okay? Example 11. Consider the cubic equation, blah, 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 blah. Algebraically determine the 0. So in your head, you need to think zeros mean x-intercepts, and x-intercepts mean y equals 0. So what does that mean? You come up to the equation and you set it equal to 0. So I get 0 equals x cubed minus x squared minus 12x. Now guys, the only way to factor is to algebraically, I'm sorry, I said that wrong. The only way to algebraically solve it is to factor. So you need to think that you have to factor. So I'm going to divide out an x from each of them, and I'm left with x squared minus x minus 12. Okay, now keep going here. Carry down that x, and you have to factor. You're saying what multiplies to negative 12 but adds to a positive 1. It's going to be x minus 4 and x plus 3. At this stage, here I'll copy it over again up here. You're going to set everything equal to 0, even including this one, guys. So you get x equals 0, you get x equals positive 4, and you get x equals negative 3. So there's 3 zeros there. Okay, there's 3 right there. All right, part B, sketch the graph of this function. Okay, so now you already know where the zeros are. The zeros are at 0, negative 3, and positive 4. So there's my zeros. And then I'm just going to put this in the graph, and I find out that my max is at negative 1.69, 12.6, and I also have a minimum at 2.36, negative 20.7. Okay, so then I graph those. So negative 1.69, and then I'm as high as 12. So don't forget, half of 25 is 12.4. So you're a little bit above that at 12.5. Half of 25 is 12.5. So you have to be at 12.6, and you're at negative 1. So you're right, maybe right around here. So here's a maximum right there. Okay, so there's that one. And then you have a minimum at 2.36. and it's negative 20. So if this is